Okay, so let's take a look at part 2. Now, I've just titled this Forms. In a second, you're going to see why. It kind of relates to what the curriculum says. And let me explain what I mean by this word forms, okay? So what this section of the curriculum says, and honestly, what it says is very little, but what it means is significant. This is a big part of what could be on your test, is that it says you need to solve linear equations of any of these 6 forms. Now, we're going to talk about this more in a minute, but there are 6 forms of the equation. Now, forms just means where the variable's placed and in kind of different sort of orders in which it lines up these expressions. Pardon me, these equations. Yes?
You have 4 twice.
That's fine, yeah. So there's a big description down here. I'm not going to read that all to you, but again, that's right out of your math curriculum. Every Manitoba grade 9 math student gets this same content. So I'm just presenting it to you, and let's take a look at what it means, okay? So by forms, again, I'm meaning how we manipulate the algebra, okay? So for example, 2x plus 3 is just an expression. It doesn't have anything you can solve, okay? The expression could equal anything depending on what you choose x to be. So for example, if x is 3, then the whole thing becomes 9, right? 2 times 3, 6, plus 3 is 9. But if we change the value of x, then it's going to change what it becomes. In order for it to become an equation, the expression now has to add an equal sign, okay? So now if I say 2x plus 3 equals 7, x can only hold one value for that to be true, okay? If x holds a different value, it becomes false, okay? So x in this case has to be 2, right? 2 times 2 is 4. 4 plus 3 is 7. If x is anything other than 2, it becomes false, okay? That's very different than what you see up here when it's just an expression, okay? So the second you put an equal sign into it, it becomes an equation, and it takes on a form, okay? So this is what's called a conditional expression or an equation because it's now based on the condition that makes it true, okay? So any other value for x makes it false. So the second you put an equal sign in there, like you see up here, now it's an equation. Now we can solve for x. Okay, which we have done before, okay? What the math curriculum says is you should be able to solve these things in various forms. So we're going to go over these in detail in this in a second, but the letter A and the letter B and the letter C and D and E could be any number, okay? So for example, this could be 5x equals 10. That's an example of that form of an equation. And then you go all the way down to some of these end ones where, again, it could, A, B, C, D, E, or F could be any number, okay? And actually, they don't have to be whole numbers. They could be decimal numbers. They could be fractions. We're not going to sort of dive into that too much right away. Generally, they're just some form of rational number. Okay. Now, here's the good news. You've already been warming up for this. In the last unit, you already did this significantly. So a lot of what we did in the last unit just carries over. So here's the good news. There is no notes for today's presentation. None. Because what I'd give you for notes, you've already done, right? So the method of solving equations, the inverse operations, the 6 steps that you guys did in the last unit test, happens again. That's how you're going to solve it again. The only maybe slight difference is now at step 6, we didn't do too many equations that involve fractions. But I am going to show you how that works in a second, okay? So other than that, it's essentially the exact same step-by-step process that you just did in the last unit, okay? Now, when we bring fractions into the equation, we have to think about it this way, okay? When we had a coefficient multiplying a variable, we got rid of the coefficient by dividing by the coefficient. That was step 6. However, you're going to get times when you end up with stuff like this. X over 2 equals 5. Or 10 over x equals 5. How do I solve that? Because in this case, I can't divide by a coefficient. remember, this whole process is called the inverse operations method for a reason. Inverse essentially means opposite. So when we do the opposite of multiplication, we did division. In this case, x over 2 as a fraction means x divided by 2. What's the opposite of division? Multiplication. So what we're going to do is multiply by the denominator. Okay, so here's the example. X over 10 equals 5. What we need to do is multiply both sides by the denominator. So I'm multiplying both sides by 10. What that essentially does is it wipes out the fraction. Kind of, okay? What it does is it wipes it out, but it leaves sitting there whatever's left over, okay? So let me show you this in more detail. Okay, x over 10, okay, equals, what did I have? 3. Let's just go with that, okay? So to solve this, I'm going to multiply this side by 10. What that essentially does is it cancels out both 10s. And what's left over? Just x. But what I do to one side, I have to do to the other. So I multiply this side by 10, and I get 30. And think about it. Does that not make sense? 30 divided by 10 equals 3? It does. So that's the process, the inverse. Multiplying, the opposite is dividing. Dividing, the opposite, multiplication. Now, it gets a little trickier when your variable's the denominator. So in other words, we use the same one, okay? So you'll know what the answer is going to be. So it's going to be the same thing, but instead I'm going to put x at the bottom. I'm going to put 30 at the top, and I'm going to put 3 there. Now we know x is going to be 10. We know that. But how do we solve for that? Okay? Well, we do the same thing. We don't stop. To get rid of this fraction, we multiply by the denominator. And guess what that does? In this case, it removes the x. And I'm left with 30. But wait a minute. What I do to one side, I got to do the other. So now I multiply this by the denominator. And I'm left with that. So now we're here. We have one more step. So we've added an extra step. Can anyone see what the step is? What's the step?
Divide by 10.
Not divide by 10. Who else knows? Andre? Yeah, you divide by 3. So we're back to this. These two cancel, and x equals 10, right? So when the variable's the denominator, you got to take an extra step. But it's still solvable. It's absolutely solvable. It's just that one extra step, right? And you can see that's all explained there. By the way, one thing you might be confused by is now the variable's over here on the right-hand side. That's okay. You can still, that's not a problem. Like I think I wrote it this way, but I shouldn't have. I should have written it the way it should have been calculated here. That this is 10 and this is x, right? Now it's lining up. But it doesn't matter. You can still flip it around. 10 equals x is the same as x equals 10. They are equivalent. So you don't have to necessarily worry about the fact that the variable's on this side. So if we go all the way back to that step-by-step process, and again, for some of you this might be confusing. Shh. But if we go all the way back to here, where is it? Let me go back. Oh yeah, right here. In step 2, or pardon me, in step 3 and step 4, it doesn't really matter which side you're putting your variables or your constants, as long as they're both on different sides, okay? For some of you that might be extra confusion, so maybe stick to the plan. But in general, it doesn't matter which side you're putting it on, because it's that balancing act again. As long as it balances, you're okay. Okay, so that gets us all the way to there. Okay, so let's do a couple of these to wrap up today. This one I don't even think I need to do it on the smartboard. This one should be fairly simple for you guys. That's a linear equation of that form. ax equals b. So we just divide by 5. We get 2. And we can prove it. Another word for proof, by the way, is verify. We can verify this by just putting our answer back into the equation, and we're done. That was an easy one. Let's move on. Now, the form gets a little more complicated. This is form ax equals b plus cx, or an example. So notice 5 is the a, 4 is the b, and 3 is the c. So with this one, got a couple more steps to do. So with this one, I would have to remove the 3x from this side. I would then get 2x equals 4. I would then divide by 2, and I'd get x equals 2. And I'd verify it or plug it back in to make sure it works. So that's that form of linear equation. Okay? The next one. Now this one uses brackets. Okay? So you can see, this one I think I will do on the smartboard. So 5 times x plus 2 equals 25. Okay? Okay, so step 1 is to remove the brackets. We remove the brackets using distributive property. 5 times x, 5 times 2. Let's rewrite it. 5x plus 10 equals 25. Honestly, that's the hardest step for most students that they might mess up. Now, the next step is no constants on this side, no variables on this side. So to get rid of this constant, I subtract 10 from both sides. Let's rewrite it. 5x equals 15. Final step, isolate the variable by dividing by 5, both sides, leaving me with my final answer, x equals 3. Okay? You've been doing this. It's just now you understand that what the math curriculum expects you is to do it of that form. Okay? And then I could verify it. I'm not going to do that on the smartboard, but you can see it here. I just verify that by plugging my answer back into the equation and making sure both sides balance. Next form. ax plus b equals cx plus d. What's different about this form is you have variables on both sides and you have constants on both sides. Now, process is the same. Okay? So the solution for this one is to get rid of the 2x on this side and to get rid of the 10 on that side. Once I do that, I should be left with 3x equals 24. Then divide by 3, x equals 8, plug it back in, and it balances. Okay? This form here is probably the most work, okay? Because in this one, I have both variables on both sides and brackets on both sides. So I have to use I have to use all 6 steps to get this one done. I have to use distributive property. I have to remove x's from one side. I have to remove constants from one side. I have to combine like terms. Lots of work there. But in the end, I'll get down to negative 3x equals negative 3, divide by negative 3, and I get x equals 1, and it verifies. Okay? So if you've been practicing these types now in the different forms, this should be easy, okay? This should be easy. The more practice definitely helps, okay? Now, the new ones that maybe will be a little bit tricky are the ones using fractional division here. But now you have that process. The process is multiply by the denominator, okay? So when I multiply by 2, it gets rid of the 2, gets rid of the denominator, and x equals 10. So that was an easy one. Now, if the denominator is on the bottom, the process is the same, but I got that extra step to eventually get down to my final answer. Okay? So that's it. That's the content here. Basically, the forms of linear equation, and this isn't even in notes, so this is just me mentioning this, is how the structure of the equation looks. How many variables? Which side of the equal side are they on? Does it involve multiplication? Does it involve division, etc.? Okay? Good news. We can just use a lot of the stuff we learned in the last couple units, any of the algebra units, to help work through this. And then the final piece is just that extra piece about fractions. And it's not that I haven't told you that before, it's just that now I wanted it formally presented to you guys because you're going to be doing more of those types of questions. Okay? That's what it said, and I think you guys are ready, okay? I think you guys are ready for this assignment, the new assignment. So let me just shut this down.